Good afternoon. I believe it's evening here. All right. So our topic or our conference paper is hybrid stacking ensemble method for credit card fraud detection. A very interesting topic, I might say. Um, we do know that digital systems have grown quite rapidly over the years. Over the past decade, transactions are getting faster and, more convenient, I would say. But this growth has definitely led to a significant increase in some form of credit card fraud cases, okay, worldwide. And traditional systems are struggling to keep up with the huge volumes and complexity of these transactions. And so there's a need for a strong, um, intelligent, and automating system that can detect these fraud quite quickly, efficiently, and without any form of bias. So our conference is, or our paper is motivated by these three things. Manual detection being impossible because it is practically impossible due to the scale of the data. And then also the constantly evolving schemes that are coming up worldwide. And so as these schemes are becoming more sophisticated, we need to evolve with the schemes. And I do say that we also need to probably get further ahead of the schemes so that we can prevent the schemes, so that we are not always on the tail, but try to be at the front of these schemes. And then also a solution to this particular problem is by implementing some form of AI or machine learning as a solution to this problem. Now, fraud detection presents several key challenges. And usually the data set that we tend to get from companies or from individuals or from our own data acquisition, we realize that the data sets are highly imbalanced. What that means is fraudulent transactions are very rare compared to legitimate ones. And so we also see that the patterns involved in these fraud schemes are quite complex, non-linear in their nature, making it quite difficult to model. And so when there's a missing fraud case, it can actually lead to a lot of financial loss. And so once we see these kinds of patterns, we need to try and come up with relatively efficient machine learning algorithms that can predict these cases. So we've set up a couple of objectives, four main objectives: to develop a hybrid ensemble method. That means that we're going to combine a couple of machine learning algorithms, not just focus on one, because focusing on one has its own issues. And so once we are able to find an average between a couple of machine learning algorithms, we can probably say we have a much better chance of detecting the fraud. And then we also want to apply some smooth and feature standardization because of the imbalancing, or because of the imbalanced data set. We need to employ the smooth to try and balance the data set so that we can make a meaningful algorithm to be able to predict. And then also comprehensively evaluate modern performance metrics on the credit card fraud detection data set that we have. And then also compare that with other various methods to see how our system works. Basically, this is the structure of the system. So we have a credit card transaction. We pick up the data that has been ingested into this particular transaction. We explore the data. We do some data processing, and then we split the data into the training set and then the testing set. And then we employ some model training, including some typical machine learning, classical machine learning algorithms, and then employ an ensemble method so that we can evaluate the accuracy of the ensembled method. In architecture, we'll do four main things. We take up the base model, we look at the predictions from the base model, And then we find the meta learner, which is pretty much going to be the main algorithm, or the algorithm that performs the best. And then from there, we can get the ensemble method. And how we're going to measure this particular algorithm is by looking at the accuracy, precision, the recall, and an F1. In our ensemble method, we got an accuracy of about 97.39, precision of about 97.34, recall 97, and also F1 97.39. Very good score. So we know that our system works very well on credit card detection from the data set that we had. And the confusion matrix was able to tell us whether our algorithm was able to pick up the true positives or the true negatives, and then the false positives, the false negatives. We have a high turnout of true positives and true negatives, which is really good, and very low false negatives. So this is very acceptable in and then we also compared with other algorithms to see how well the algorithms also performed individually. And random forest did do much, much better, which is a decision tree based algorithm. So that performed much, much better. The support vector machines also did do a good job, but the lowest was the logistic regression because it is a non-generative learning algorithm. So in the performance, we can see that right from here, random forest performs best across all the performance metrics. And our ROC curve also, and our area under the curve, also we got 0.96, which basically tell us the strong separability. In conclusion, these are what we found. We evaluated five main metrics: the artificial neural networks, logistic regression, random forest, and SVC. And then we achieved some very high performance. And so we'd want to go with an ensemble method of all of these four, taking an average of all of these four and using that as their main output, because these four algorithms are able to pick the linear and non-linear patterns that exist in a data set to be able to give us a good prediction in a credit card fraud detection problem. In the future, we tend to add some more adaptive learning. Also try to advance that into deep learning methods, much complex or more efficient deep learning methods. And we also want to test it on much larger data sets and also on real-time data. So you see, one of the things that we realized is the data set we had here was a data set that existed. But however, if we have a dynamic data set or a live data set, how will we be able to react towards that? So that's the next step, to reacting towards a real data set. Thank you very much.